When we talk about states of matter at GCSE, what we're talking about are three things. We're talking about solids, liquids, and gases. And you've come across these three states of matter lower down in the school, probably year 7, and have talked about them. And a lot of this stuff that we're going to cover should be quite familiar to you from lower down in the school anyway, but we're going to recap it. So when we're talking about solids, sometimes you're asked to draw a particle diagram. And if you're asked to draw a particle diagram, what you're going to draw is some circles that are all touching and that are in a really regular pattern. So this would be a good example of a solid. And that is because a solid has a fixed shape and it also has a fixed volume. So what we mean by fixed volume is that it can't be compressed. Because it has a fixed shape, it can't flow. And the particles vibrate around their fixed positions. So they have a higher density, or a much higher density than a gas. Most of them have a higher density than the liquid, so much higher density than a gas. And they are the lowest energy out of the three states. So you need to be comfortable drawing a solid. And then the properties, again, fixed shape, fixed volume, the particles vibrate about their fixed position, they have a much higher density than a gas, and they're the lowest, the particles in it are in their lowest energy state. For a liquid, again, you need to know how to draw the diagram, and usually it's in a container, and we would draw particles that are still touching, but they're not in any kind of arrangement, so it fits the container shape. And you've seen this yourself when you've poured a liquid from something, that it will take the shape of the container that it's in. So we would say that it can flow, and this is because the particles can move about. So they can slide over each other to take up a new position. It also has a fixed volume. And as we just said a couple of minutes ago, if it's got a fixed volume, that means it can't be compressed. So the particles are still in contact with each other, so that's why the volume is fixed. It has a higher density than a gas. And it has more like the particles have more energy than the solid, but less energy than the gas. So they're in the middle there. And with gases, often we draw them contained in a box kind of shape, and you would only draw kind of 1 or 2 particles, certainly no more than 3. And sometimes we draw these little lines, and these little lines represent the fact that gas particles move the most. So let's just kind of continue on with the properties that we've talked about with solids and liquids. So in terms of the shape, it fills the container. So like with a liquid, it will take the shape of the container, but a gas will spread out and fill the container. And we can also say that it flows. The particles move. At random, but they're also at fast speeds. Okay, they are much further apart they're not touching each other, and this is why we say they're the least dense out of the 3 states. We can say that the volume can be changed, and the reason that the volume can be changed is the fact that there's all this space in between these particles. So if we move, like compress it, so we move the particles closer together, then we'll be able to change the volume, and this has the most energy out of the 3 states. So that's the basics of what you need to know about states of matter. You also need to know that we can change a substance from a solid to a liquid, and from a liquid to a gas, and then vice versa. So we're just going to very briefly go through the names of those changes of state, and then in a later lesson you will learn about how that happens. So let's say that we're going to heat something up. If we heat something and it turns from a solid to a liquid, we would call this melting. If we heat something up and it goes from a liquid to a gas, then we would call that boiling, or sometimes we call it evaporation, which are slightly different things, but we'll do that in another lesson later on. We actually go a little bit further at GCSE than we did in year 7, and we talk about things that go from solids straight to gases. So they bypass the liquid stage. So it goes straight from a solid to a gas, and this is called sublimation. And you might have seen this with like frozen carbon dioxide or dry ice, where it goes from its solid state and it goes straight to a gas, so it's not a liquid at all, and the technical term for that is sublimation. So that's a new key word for this topic. So let's say that we were cooling something down, and let's think about what we would call the changes of states in the opposite direction. If we're going from a gas to a liquid, then we call this condensing. So you get condensation on your windows. Say you're cooking dinner and it's quite cold outside, so the glass of the windows is quite cold, you generate lots of steam. That steam then hits the cold surface and it turns from a gas, from the water vapour, from the steam, back into a liquid. It's called condensing. And then if we go from a liquid to a solid, we usually call this freezing. And we can get mixed up sometimes because in everyday language we use the word freezing to mean something that's very cold, because we think of it in terms of water, and water freezes at 0 degrees. So let's write that here, 0 degrees Celsius. Whereas if we were talking about this with, let's say, like metals would turn into a solid from cooling from a liquid at a much higher temperature, and so it might feel a bit confusing that we're talking about something freezing when we're talking it happening at a couple of 100 degrees. So you might also see the word solidifying sometimes, which just means turning into a solid. So freezing would be what we properly call it, but sometimes you'll see it as solidifying. And then if we think about going from a gas straight to a solid, so the opposite of sublimation, that's just condensing again. So I will write it, but it's not another new word, it's just the same word as from a gas to a liquid. So the thing that we need to know for so we've already said about water, its kind of freezing point and its melting point is the same, so 0 degrees Celsius, and we should also know that the boiling point of water is 100 degrees Celsius, which means that it's also going to condense at that temperature as well.